Hello and welcome to another video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 25, Diamond in the Rough. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Knight. The same number cannot show up twice within a knight's move, 2 over and 1 across in any direction. So anything like that, etc. Killer. The cells in each cage must sum up to the number in the top left corner of the cage, and numbers cannot be repeated inside the cage. Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. German Whispers. Adjacent digits along the green line must differ by at least 5. Renban. Digits along a purple line must form a consecutive group, but they may appear in any order along the line. Without further ado, let's begin. That's quite a long list of rules, so I really hope that I can get this puzzle done in one try, so that I don't have to read all 2 of them again. So we have 2 cages that sum up to 15, and there's 2 ways to get that. It's 9, 6 or an 8, 7, right? And over here, we have cages that sum up to 5. And we do see, in fact, that they go downwards here and to the right over there. And they're at least 2 cells long, and we know that they cannot possibly be 3 cells long, because the minimal value you would put in those 3 cells are 1, 2, and 3, which already sums up to more than 5. It sums up to 6. And so they are at most 2 cells long, and therefore they contain numbers 1, 4, or 2 and 3. All right. Let's just quickly fill in every other possible value of every other square in this grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start by assuming that this square over here is the number 1. If that's a 1, then this has to be a 4 because they sum up to 5. Since these 2 are a Renban line, they form a consecutive group, so this has to be the number 3, and then this is a 2. We notice that these are all unique numbers from 1 to 4. That will be very relevant. So now let's assume that this is the number 2. If that's a 2, then this is a 3. And now this is either 2 or 4 because they have to be consecutive. But it cannot be the number 2 because this is a knight's move. And if you remember the knight rule, it says that the same number cannot appear twice within a knight's move, 2 over and 1 across in any direction, right? So therefore, this cannot be the number 2. So it has to be the number 4 because it has to be consecutive with the 3, meaning that this is a 1. So once again, you have 4 unique values from 1 to 4. So what if this is a 3? If that's a 3, then this is a 2. This cannot be a 3 again, right? Because it would contradict the knight's rule with this 3 over here. So then it has to be the 1 because they're consecutive, 2 and 1. So then this is a 4. Once again, you have 4 consecutive values. And therefore, if this is a 4, this is a 1, this is a 2, and then this is a 3. So in all possible ways, you have exactly 4 unique values in these 4 squares, and so you have from 1 to 4 in these 4 squares in some configuration. Now, if you take a close look at these 4 cells that I just selected and this central square, you will see that these 4 cells all see this central square. Namely, this cell is in the same column as it, this cell is in the same row as it, and these 2 cells see it in a knight's move, right? From that side and from this side. So since we have 1, 2, 3, and 4 in these 4 cells in some configuration, and all of these cells see the central square, then the central square cannot contain 1, 2, 3, or a 4. So no matter the configuration, 1, 2, 3, 4 is there, they all see this square, so you cannot have those values. So let's try downwards. This is a 6, for example, then this is a 9, and this is an 8, 7. It's all unique values. If this is a 7, this is 8. Now this cannot be a 7 again because of the Knight rule, so it has to be 9 and 6, right? If this is an 8, 7, 9, 6, and lastly, if this is a 9, then this is a 6, and so this is a 7 and 8. So in all possible cases, again, it's the same as before. These values have to be unique. They have to be values from 6 to 9 in these 4 squares. And since all of these squares see the central value, right? These two see it in a Knight's move, and these two share the same column in a row. This cannot be 6, 7, 8, or a 9, and therefore that is the number 5. Now that does reveal some new information. It first reveals a black Kropki, and we know that digits 5, 7, and 9 cannot appear in a black Kropki pair because nothing doubles into these values, and a double of their value is over 9. So this cannot be 5, 7, or a 9. And we also see this German line. And in fact, we see that this entire German line is contained within one box, so digits cannot be repeated. And also, each cell on a green line sees at least 2 other cells. Now, we ask the question, can the number 4 appear anywhere on this line? Well, if it could, you'd run into a contradiction because number 4 can only show up next to the number 9. But if this was a 4, for example, then it would see 2 numbers 9, right? It would, if this is a 4, then this and this both has to be the number 9 because that's the only digit that differs from it by at least 5. And so, that's a contradiction because number 9 cannot show up twice. And that's the same thing everywhere on the line, so no digit can be a 4. What about the number 6? Well, if a 6 showed up anywhere, the only number that differs by 5 from it is the number 1, so number 1 would have to show up on both sides of the number 6, which is indeed a contradiction again. So, number 6 also cannot show up anywhere on the line. And now, since this cannot contain values 4 or 6, then this cannot be a 3, and this cannot be an 8. All right. Now, we ask the question, can this value up here be the number 1? So, what is the motivation behind asking that question? Well, you'll see that if this is a number 1, then none of these 4 cells can be a number 1, because first, these 2 are in the same column as the number 1, and these 2 are seen in a Knight's move, so none of these can be a number 1. And so if this is a 1, then this would be a 4, then this is a 3, and then so this is the number 2. But now, since this is a number 2, these 2 are not number 2, and these 2 are not number 2 either within a Knight's move. So none of these are number 2. And now immediately you see a problem. Basically, you have 4 values, right, on a green line, and you know that 2 of these values have to be high values. They have to be above number 5, and 2 values have to be low values. They have to be below 5 in order for the German whisper line to work. However, the only low value you have is the number 3. And number 3 cannot show up twice on this line. So, for example, if this is a high value, if this is an 8, then you would need to have a low value on both sides. You need to have 3 and 3 again. And that doesn't work. And if this was a low value instead, then this would have to be a high value, but this has to be a low value, and you've already used up the 3, so you run into a contradiction. Therefore, number 1 cannot show up over here. And in fact, it's completely the same if you assume that it shows up here. Because if this is a 1, the number 1 is nowhere here, right? And then this has to be the 4, this is a 3, and then this is a 2. You run into the same configuration where you have 1 and 2 in these 2 cells, right? And therefore, this also does not work. So number 1 cannot show up here. Can a number 2 show up here instead? Well, If that's a 2, then this is a 3, because they make a 5. This cannot be a 2, because digits are unique. We've already proven that. So this has to be a 4, and then this would have to be a 1, but it cannot be a 1. Therefore, this also cannot be the number 2. And it's same from this side. If this is 2, then this is 3, this is 4, and then this would have to be the number 1. And that does not work. So this cannot be the number 2 either. And now we've placed the 3, 4, 3, 4, right? So obviously in order to make a 5, this cannot be a 3 or a 4. So that's a 1, 2, 1, 2. Now, we don't know which is which, but we do know some stuff. For example, this cell right here cannot be a number 1. Why? Because it would force both of these cells to be a number 2, and we've shown the digits don't repeat from here in this group, right? It's digits from 1 to 4. So this cannot be a 1, oops, and it cannot be a 2 for the same reason. It would force both of these to be a number 1. Furthermore, we can show some more stuff. For example, this cell cannot be number 1 or 2. Why? Because this cell sees it directly within the same column, and this cell sees it within a knight's move. So if this was a 1, then this and this would both have to be a 2, which is a contradiction. So this cannot be a 1 or a 2, because these two, as we said, both see it. Now this cell also cannot be a 3 or a 4, because this thing sees it, and this thing sees it as well. And it's same for this thing. So this cell is also seen by this cell in the same column, in the same row, and this sees it in a knight's move. So both of these cannot be a 3 or a 4. Now, same is true for this thing actually. So this cell sees it in the same column, right? And this cell sees it in a knight's move. So it cannot be a 3 or a 4. Because if this was a 3, then both of these would have to be a 4, contradicting the fact that these have to be unique. Okay, that is that everything? No. So this also is seen by this cell and this cell in knight's move, so this cannot be a 3, 4. And this thing cannot be a 1, 2, so this sees it in the same row. This sees it in a knight's move, so this cannot be a 1 or a 2. And more or less, I think that might be everything. So if we're missing something, that's fine. We'll do it later. But this cannot be a 6 because there's no number 3 over here. And therefore, this must be the number 4. So then this cannot be the number 1. And so that is either 2 or an 8. Okay, so that does reveal some new stuff. Namely, it reveals the fact that we have a green line that goes like that. And we are going to promptly remove coloring from these two because that is no longer necessary. And we're going to color the green line. So this is a low value. So this has to be a high value. So this cannot be 1, 2, 3. It also cannot be a 6 or a 7 because the lowest value here is a 3. So now this has to be a low value. Obviously number 5 cannot show up anywhere first. So this is a low value. It cannot be 6, 7, 8, or a 9. And now this also has to be a high value. So this cannot be a 1, 2, a 3, or a 4. And this is also high value. So this cannot be 1, 2, 3, or 4, or 6 or 7, because as we said, 8 is the 3 is the lowest value here. So we have an 8-9 pair in this box, meaning that this and this cannot be an 8 or a 9. All right. So immediately we know that this cannot be a number 4 because it will need to have number 9 show up on both sides. And they're both in the same box, so that does not work. And therefore, this must be the number 3. So since that's a 3, then this is the number 2 to make the 5. And then this has to be the number 1. and then this is the number 4. Okay, so since the number 4 is either here or here, then the number 4 cannot show up anywhere else in the same column. So since the number 4, actually never mind, it can also be here. So let's be careful. Well, this is a part of the line, right? We now see that this is also a part of the line, and it must contain a low value, and the only low value it can contain is the number 3. Okay? So let's check the numbers 3 now. Number 3 has to show up either here or somewhere here, meaning that it's nowhere else in this box. Number 2, number 4. The issue with the 4 is that this can be the 4 and then this and this can be a 9 because they're not in the same box. So this is probably the next place to look. Maybe this can be resolved somehow in the similar way that we resolved the initial case. So we see that numbers 1 and 2 show up on the green line. Number 3 doesn't show up on the green line in here. So the lowest value of 7 already works. Number 6 doesn't show up anywhere. I'm not sure if I should spend time thinking about that. So let's try doing this instead. If this is a low value, so if that's a 2, then this would be the 1. And then this can be anything almost. And instead, yeah, not sure. Not entirely sure. Maybe I do have to think about this. So let's assume that this is an 8. Well, if that's an 8, then an 8 does not show up anywhere there or there, right? Or here. So no 8 in this thing. So if that's an 8, then this would be the 7. And so this would not be a 7. And now this has to be a 6. Oops, this has to be a 6, and this has to be a 9. So there would be no number 9 anywhere here. And that does run into a contradiction, actually, because then number 7 would be the only high number on the green line. So that does not work. Number 8 cannot show up either here or here, because if it did show up, then the number 9 would be on the other side, which would force number 7 to be the only number on the green line. Okay, that makes sense. So let's just do that again from the other side, just to maybe explain it slightly better. So if this is an 8, the number 8 cannot show up in the same row, and it cannot show up here or here because that's a knight's move. So since this is an 8, then this has to be a 7. Oops, this has to be a 7 to make the 15. Now this cannot be an 8 again, so it has to be the number 6 because these two are consecutive, right? And so this has to be the number 9 then. So a number 9 cannot show up anywhere here. meaning that the only high number on this line is the number 7, but there must be 2 high and 2 low numbers, which is a contradiction. So number 8 cannot show up. Oops. Number 8 cannot show up here or here. And for the same reason, let's assume that this is the number 9. If that's a 9, then this is a 6. So then this is a 7, and then this would have to be the 8, but it can't be the 8. And it's the same the other way around, so neither of these can be a 9. And so this and this cannot be a 6 or a 7, because these have to sum up to 15. So now this cannot be an 8, 9, because this thing sees it in the same column, and this sees it in a ninth move. This is not 8, 9. This is also not 8, 9, because both of these cells see it. And is there anything else? No, I don't think so. Let's try the 6, 7. So this cannot be a 6, 7, and this cannot be a 6, 7, because this sees it and this sees it in a ninth move, so this cannot be a 6, 7. And now this is an 8, 9 pair, meaning that you cannot have 8 or a 9 anywhere there, meaning that this number is the number 2, and now there must be this must be a high value, and then this must be the other low value, and that must be the number 1. Okay, so 7, 3, 7, 8, 9, 7, 6, 7, 6, 8, 9. Okay. So a 7 cannot show up here or here, because this thing sees it and this thing sees both of those two cells. So if this was a 7, then this would have to be a 6 and this would have to be a 6, and we've proven that all of these numbers are unique from 6 to 9. So this and this cannot be the number 7, and so that is another 8, 9 pair. So nowhere else can you have an 8 or a 9. All right. I think that's probably everything with this central square. So 4, 1, okay, 2, 3, 5. We're still missing something important. It's something pretty important. So 6, 7, 6, 7, there's nothing else with them. 8, 9. Oh god, I really hope it's not these other squares that they see. I mean, this and this cannot be an 8, 9, right? Because they see it in a ninth move, and here they see it in the same row. So this cannot be an 8, 9. I really hope it's not this. It's gonna be a bit annoying if that's the case. So it's probably not this, but I think this is a valid step. So this thing cannot be a 3, a 6, or a 7. Why? Because if it was a 3, then the 3 would not be here, and the 3 would not be here. So that would be 6, 7, 6, 7, 6, 7, which is a contradiction. So this cannot be a 3, a 6, or a 7. And now we have an 8, 9, 8, 9 pair. This is all valid. I just highly doubt that this is the right way to approach the puzzle. There has to be something much simpler that we are missing. And now 8, 9, 8, 9 cannot be anywhere here, right? Because we have that pair. Obviously, this cannot be a 6, 7 either, because of this and this. So 6, 7 cannot be there. I feel like it's probably this thing. That's so I think this. So how do I explain it? If this is a 4, then both of these are a 9, and then number 9 cannot show up on this line, and we know that number 9 must show up on the line. So if this is a 4, then this is a 9, and then this is a 9, and because of this, then this is not a 9, and because of this, then this is not a 9. But we've proven that this line contains all numbers from 6 to 9, so we run into contradiction. Therefore, that is not the number 4. So then this has to be the number 1. Okay. And now what? Now we still know that both of these are not 9, but this can be a lot of stuff. So number 1, nothing new. This is a really fun puzzle, but it is getting a bit rough. So we have a 6, 7, 6, 7 pair, meaning that this cannot be a 6 or a 7. What else can we do? Yeah, it's Not completely obvious to me. Oh, maybe. So now that we placed the 1, we do have some new information. We actually see, I'm blind, we see that this extends downwards. And since this is a high value, then this must be a low value. And so it must be the number 3, because that's the only low value left. And now this cannot be a 6 or a 7, because it's next to the 3. And, okay. Now we see the entirety of this line. So we can remove this. And this line goes like this, so it cannot contain the number 5. Okay. We're making some progress. It's slow, but it is progress. So 3 must go here. And that reveals another German whisper, so number 5 cannot go there. I was hoping for a cleaner number 5. I guess that's too much to ask for. But number 6 cannot show up here because there's no number 1 to pair with it. Number 4 can show up. It can be just a 4-9. Right? So number 4 is definitely somewhere down here, meaning that it cannot be anywhere here. And so since number 4 cannot be... So 6, 1, 6, 1, that could be the case. In case this is just a short line. Okay, so number 4. Oh, number 4 is here in this box, because no other square can contain it now that we've cleaned it up down there. So this is number 4. And now we see that the line extends. So this is also not the number 5. All right. So 1. Number 1 must be down here, because it's the only place for the number 1. That's a 1. And now this has to be a high value. And now this has to be the low value, and the only low value it can take is the number 2. Okay, and now this cannot be a 6 because it must differ by at least 5 from the 2, so this is the 7. All right, and this is a 6, 9, and now this has to be the 8, and then this has to be the 7. So this is 9, 8, 9, 6, 2, and so the 2 is here. Neither of these are the number 5, and this cannot be a low value, it must be a high value, so it must be a 7. This cannot be a 4, so it must be the number 1, and so 8. This is a 9. This is not a 3 or a 6, and so this is 4, 7, 5, 4. This is not a 3 or a 5. So this is a 7, 8, 6, 1, 9, 5, 6, 5, 4, 1, 8. These two are consecutive, so this is a 9. This is a 6. So this is 7. This must be a low value. So this is 8. And then this is the number 2. These two must be consecutive, right? So this must be the 7. And then this must be the 8, 9, 6, 7, 9. This is a 4. And these cannot contain the number 5. So this is the 5, 6. And this is an 8. So this is a 5. 3, 6, 5, 6, 3, 9, 8, 4, 1, 3, 7, 2, 5, 3, 5, 4, 3, and the puzzle is complete. So the puzzle just kind of gave up on us immediately after we solved the difficult part. There are some puzzles like that where as soon as you're done with like the crucial difficult part, it just all falls apart. But I still feel like I played pretty badly. I got pretty stuck, and it took me quite a while. I feel like, I don't know, maybe that's not the case. I'll rewatch the video myself. But I feel like I got stuck for like 3 minutes without any clue what to do next. But it was a really fun puzzle, honestly. I really loved the central part of the puzzle. I feel like there are really clean steps that you can do to deduce what happens next. And I always love it when you don't have to just spend time brute forcing, when you can just think in general terms and derive the solution. I think it's really beautiful. So thank you guys for watching. This really was a diamond in the rough. And see you in the next one.